Hello again. Today we're going to talk about different types of exponents. Now you've seen positive exponents and negative exponents and zero exponents, but now we're going to talk about exponents that are fractions. Okay. Now exponents that are fractions have everything to do with roots, the type of roots you're taking, and the exponent underneath the root. So let's go over the vocabulary of roots. The type of root that you're taking is called the index. So the little number here is called the index. And you know that when the index is 2, we do not write it. So when equal to 2, we don't write it, okay? Or we just write the square root symbol. Okay. The radical is this symbol right here. So this whole thing is called the radical, right? This is the symbol right here. Regardless of whether we're taking whether we're taking a square root or a cube root or any other type of root, this is still called the radical. And so the entire thing underneath the radical is called the radicand, okay? So in our situation, the radicand is itself a power. So this whole thing is the radicand. Now we have another piece of vocabulary here, particular to this situation. This is called the exponent, of course. So 8 squared is the radicand, 8 is the exponent, and 2 is the exponent, and 8 is the base in this situation. So there's a lot of things going on here. We are taking the third root of 8 squared. So what we're doing is we're squaring 8. So 8 times 8 is 64, and then after we get 64, we're taking the third root of 64, okay? This is what we're going to be talking about today, this type of problem. So another type of notation that we can use here, instead of roots and exponents, is we can translate this to actually have fractions as exponents, okay? So this fraction is a little funny because there's a lot of space between the numerator and denominator, but this is the same thing as 8 to the 2/3. So the fraction, or the exponent on 8 is 2/3, okay? So this is what we saw in the last on the last page, that 3 was the index, 2 was the exponent, and the radicand was 8 squared. So one way you could write this is, you could write the squared underneath the 8 as a radical symbol. You can write the squared with the 8 as the part of the radicand. But another way you could write it is actually you could bring the exponent and raise the entire root to the second power. That's just another type of, another way you could write it. And it's going to be advantageous for you to write it either this first way or the second way. And you're going to have to identify which one is advantageous to you based on the type of root you're taking. Okay, and we'll talk about that more when we get to simplifying. So these two are equivalent, right? Writing the squared underneath with the 8 is equivalent to writing the squared, to putting the entire thing, the entire root inside of the base of this exponent. Okay. Now another way you could write it is rewrite it with fractions. Now notice that there's two different components here. The exponent right here becomes the numerator of the fraction, and you should write that down. And the type of root that you're taking becomes the denominator, and that is always going to be the case here. Okay? So another situation is you have the fourth root of 7 cubed. You can write it as 7 to the 3/4 power. Okay? So the index becomes the denominator, and the exponent becomes the numerator. That's just another way of writing that. Okay, let's actually get to simplifying this situation. Now, before, the two fractions that we saw were not unit fractions. We had 2/3 and 3/4. Let's talk about what happens when you have unit fractions here. So we can rewrite 64 to the 1/3 as the third root of 64 all raised to the first power. So again, notice the parts here, that the root is the denominator, and I used different highlighters than the last one. So this was the root, and the numerator becomes the exponent. Okay. Now in our situation, we could also rewrite this as the cube root of 64 to the first power. Either way, it's going to be fine for us. Well, 64 to the first power is just 64, so this simplifies to the cube root of 64, which we know just simplifies to 4. Okay, that's a 4 right there. So here, 64 to the 1/3 is 4. Now, in this situation, so let's do the same thing here. So this is the 5th root of 32 to the first power minus the 2nd root of, or is the square root of 81 to the first power. Now again, we don't write it as a square root, but it's easier to translate the parts of the fraction as an index. So I just wrote it here that way. Okay, so let's think about the 5th root of 32. Now the 5th root of 32 is a number that when you multiply by itself 5 times, you get 32. And that ends up being the number 2. So 2 times 2 is 4, times 2 is 8, then 16, then 32. So the 5th root of 32 is 2 raised to the first, so we have 2 to the first power essentially here, minus the square root of 81, the principal square root of 81 is 9. It's 9 to the first power. That's just 2 minus 9, which gets you -7. Okay, and that's how we deal with fractional exponents. Let's try some more simplifying problems here. So here, we don't have unit fractions, we have fractions that are not unit fractions, right? So let's think about how we would translate this. We could write this as the 3rd root of 125 squared, or I could also write it as the 3rd root of 125 all raised to the 2nd power. Those are two notations I could use. Now let's think about strategically which one's going to be better for us. So here, I don't really want to take the square, I don't want to square 125, okay, because that's going to be a long process. I may need to calculate, well, I could do it without a calculator, but let's see if I can let's see if it comes out cleanly, like as an integer if we do it this way. So the 3rd root of 125, that is actually an integer, right? That's actually 5. So here, it's easier for me to take the 3rd root first and then square it than it is for me to take 125 square and then take the 3rd root of that, because I can do this second part in my head. So let's go ahead and do that. The 3rd root of 125 is 5, and then 5 squared is 25. So 125 to the 2/3 is going to just be 25. Okay. Here, let's write the two things that we could do. Remember, the denominator becomes the type of root. So we can either do that, or we can write the 4th root of 81 to the 4th power. Okay. Let's think about the 4th, oh, that would be to the 3rd power. Whoops. Now, if it's at all possible for me to take the 4th root of 81, I want to do that first before, I mean, it's always possible to take a root, but if I can take it and get an integer value back, it's easier to do that first. So this number becomes smaller, and then when I cube it, it's a little easier for me. So it actually ends up being the case that the 4th root of 81 is 3, because 3 times 3 times 3 times 3, this is 9, then 27, then 81. So this ends up being 81. The 4th root of 81 is just 3. So I have 3 cubed, which is just 27. Okay, so 81 to the 3/4 power is the power of 27. All right, and if I did this on the calculator, I could put 81, and then I could raise it 2. And then to put a fraction in the calculator, I say alpha y equals. And here's my fraction menu. That's an alpha y equals. And I press enter because I just want the numerator over the denominator here. Okay, and I put 3, and then I arrow down to get a 4. Okay, so that's 81 to the 3/4 power. Press enter, I get 27. Notice that's the same thing if I do, if I put a different type of root in. And actually, I'm not going to, the roots are in the fraction menu. So option number 5 in the fraction menu, you can, let's see what it gives us. So actually, the first thing we have to do is put the index in. So let me clear it. So my index was the fourth root, so this, and then I put math, I choose option 5, the fourth root of 81, and underneath the radicand I want to put to the third, and that should get me the same thing, which it does. Okay, so a couple of different ways you can do it on the calculator. I would put it in as a base with a fractional exponent instead of doing it this long way, but just so you can see that those two are identical. Okay, and if you tried for 125 to the 2/3, again, you could do 125 raised to the power of, grab your fraction from alpha y equals, choose enter for the first option. So here's my stack fraction of 2. Let's see, it was 2/3. 2, and then go down to get 3, and press enter, and that should get me 25, which is what I got. Okay, and that's the end of the lesson for today.